All right, folks, thanks so much for joining. If anybody's tuning in, it's our weekly Epiphyte live stream, which we're projecting out into various social media platforms. But this is where our Epiphyte team, which is working on a small open source direct air capture. Awesome. We got Alex here too. And this is where we just decided to kind of open up the window on our process. We got folks that are from all over the place that have been working on this for well over a year. We built our first version of it in the end of 2023 and discovered some things we immediately want to optimize in order to make it more universal and available to a larger group of people. And so what we're doing this spring is we work our way towards that second build this summer, location TBD. We have a few good contenders. We're working through one after the other, the different things that we know we need to improve upon in order to build this next build. So I'll put my face up here, sorry, and I'll actually let some other folks join. Hey, Alex, how are you? Scott, if you want to turn on your camera, feel free. We'll have a couple other folks joining us too. David Wilson, who sort of was the captain of the ship for the first build, is not here this week, but in his absence, there's much to discuss. We have Alex here, who's sort of a open air hacker in his own right on another project, but I know has an interest in this. So this is actually great to have you on, Alex. Thanks for popping in.
Yeah, no problem. It's cool to see how much you guys have done in the last few weeks. So I'm
yeah,
excited to hear what's going on now.
It's been
and yeah, I'm just here to listen mostly, but maybe I'll pop in with the
yeah.
in there.
Since we have some of our core members can't join today, I thought I could do a little bit of housekeeping to show some of the resources that are, again, available for folks. Here's Seth. Go ahead and add him to the stage too, and Scott. And I know Ling will be here in a second. She's on the West Coast like you, Alex, so she has to run to work before she can get on the call. Hey, Seth, how you doing?
Good, Chris. How are you?
Great. There's Ling. Hey, Ling.
Make it on the platform today.
What's that? Yeah, I'm glad you could make it too. Yeah. You had a little technical issue last week, so great. Well, last week we, we were just kind of doing these stealthily, but we had about 34 people join, tuning in by the end of the session, so that was great. And I just sort of summarized for people where we are. And what I thought I would do just real quick is do a little bit of housekeeping, some of the resource upgrades that we did since we met here last Monday. So first, what I'll do is just share my screen, and that should work. Great. And so the first thing is, again, I've referred to this brochure. That's a dumb word for it. Why don't we call it the digital deck? And this has changed just a little bit since last week. Again, I'll drop the link in the chat there. This is the thing to just look at, get up to speed on what we're trying to do, what problems we're trying to solve immediately, and some of the future directions for this system that we've talked about here within our group. But one of the things I did add is if you scroll down through all the background stuff and the description of how the first build worked for the immediate optimization needs part. So these are, again, like last week, all the kind of main things that we're working on in sequence. Last week, we had a great session on sorbent, and I think we have landed on, unless something comes out of nowhere, we've landed on a good option for the next one. So I think we can move beyond one for the time being. The recording of that is hanging around somewhere on social media, but I'll probably add it to our forum. What I did add is I changed the forum a little bit so that we actually have, a dedicated category just for Epiphyte, which allows us to create subcategories based around the optimization areas, and these will grow and change over time, as well as our general build log. So it's a little bit easier for folks to go ahead and navigate. And what the deck now has is if you're like, oh, this looks interesting, I want to type something or see what's being talked about this specific optimization, you can go ahead and click on the link and it goes right to the subcategory. In this case, it's about sorbent selection, sorbent chamber changes. So it just made that a little bit easier. The other thing we have too is with the resources on the bottom, and I'll let Ling actually speak to this, but we went ahead and added our GitHub. We still have stuff to add, but it actually does have the most up-to-date materials. And then on the back here, the last one I did put, you can click on this calendar, and that always just gives you the links and the times for these weekly meetups. But with that, Ling, did you want to say anything about the GitHub? Again, with the understanding that there's much more to come, but Christina said,
actually, once my sister and I push, it'll be mostly in place, but David is missing a few things. Like the electrical schematic, he says that there's a few things that he wants to upload. So I'll help him with that, but yeah, the bomb stuff will be ready shortly.
Okay.
And this, of course, will be updated once, if you just send out the link, it'll always be the latest version.
Okay, awesome. Thanks, Ling. And I'll get Janine on there.
The GitHub is supposed to be meant for standalone. It's just standalone, and then someone can reproduce our work from just the GitHub.
Okay, fantastic.
That's what we're aiming for anyway.
All right, great. So, but it's got the license up there already in the README, and so it's definitely coming along.
Yeah.
But quickly back to this again. So this, anybody who's kind of watching or interested, take a look at it. But what I'm going to be doing this week is kind of sending it to various different fora and Department of Engineering and Material Science departments at schools that I know have interest in direct air capture, as well as other schools. So please do, if you think that this is something that would be interesting to your network, go ahead and take this and share it widely. All right, let me go ahead and stop sharing my screen and drop that in. All right, comments. So I just put that brochure again, which again has the Epiphyte link to it. So, all right. So how's everybody doing? Scott, I can't remember if you were on here last week or not. I know you're a new joiner. All right, cool. You want to just unmute there and maybe introduce yourself a tiny bit? Nope, just moving his thing. He'll be back in a second, but again, we have Alex, who I introduced during the first minute, who's a real open air vet who works on cool projects. So it's always great to have him pop in. Alex, you want to just quickly introduce yourself?
Sure thing. Yeah, I'm Alex. I'm a software engineer by trade, but I've been working on a few hardware hacking kind of projects for open air, including one called Synthwave. I kind of focus on electrochemical direct air capture and direct ocean capture. So yeah, Epiphyte's a little outside my wheelhouse, but it is a very cool project, and I have a few ideas of my own that I think I'll pitch at some point here. So
no time like the present. Maybe we'll get to that even in this call. Seth got stuck and couldn't get onto the call last week, but he's a core member of the team. Seth, you just want to introduce yourself for our now audience of 14?
Yeah, hey everyone, I'm Seth Sternberg. My background is in software and product management, primarily around sensor algorithms and AI. And I've been with the Epiphyte team for about a year now.
Yep, that's right. And Ling, you were here last week, and
last year also.
yeah, and last year or the year before that. So if people tune in, yeah, go ahead, Ling.
Yeah, my name is Ling Kong. I am a biomedical engineer by trade. I've worked on a lot of hardware in the past. I'm like a fake mechanical engineer. That's what I call myself, fake mechanical engineer. Currently, I work on software in my own job, but I contribute to Epiphyte mostly on the hardware side, remotely also.
Awesome, great. And then we have Scott, who's a new open air member who just joined recently. Good to have you, Scott.
I'm hooked up now. I'm also a first-time StreamYard user, so I'm figuring this out on the fly, but I think I'm good now. Yeah, as Chris mentioned, I just joined Open Air formally a couple weeks ago, but I've been kind of lurking in the this is CDR, sorry, for the last 6 months or so. Chemical engineer by trade, but I've been working on adhesive tapes and stuff for the last 30 years. So, kind of a totally different area, but I'm super psyched to get started on CDR and all things related. So,
excellent. We might need that adhesive tape when it comes to sealing. So that might come in handy for that.
Sounds good.
So Seth, you weren't on the call last week, as I said. What I thought we could do with this is last week we made really good progress on our first optimization, which is just the sorbent swap out. We've been talking about an upgrade to that Levitit sorbent from the zeolite. We had Ben Evanson joined, who's done tons of research on that for his own open source mini DAC project. And while nothing's perfect and there's always trade-offs, I think that we probably ended that call feeling more convinced that this would be a good one to drop in. And so we can go on hold. We don't need to make that order until we're ready to build. But my thought is we probably can put that to the side right now unless some other kind of breakthrough option comes. So we can move on to other stuff. But Seth, as you were watching last week or what's been going on, I didn't know if you had any updates or anything that's popped into your head that you're burning to talk about.
No, not at this point. I still need to catch the replay.
All right, cool. So what I sent you guys on the Discord, I thought that there's the many things we have to do about improving sensor performance. We've talked about that a bit, improving the airflow through the actual system so that it doesn't get blocked by the sorbent. And they're all listed very clearly in 8 different items in the digital deck. But one that is like really critically important is, because a lot of other decisions sort of hinge on it, is the changes we make to the sorbent chamber. So the sort of the metal housing basically that has the dampers on either side that the sorbent panel sits inside. And that's what closes off air, has to ultimately withstand a vacuum. And so I think we got to, kind of think creatively. And I know there's been some calls off stream, like looking at other options. So I thought we might be able to kind of, particularly with some new eyeballs in the stream today, maybe sort of talk through some high level ideas about either fixing what we have or what would be an alternate approach. Does that sound okay, guys? A little blue sky or?
Sounds great. I might actually lead off with a question, which is what kind of vacuum do we actually need to pull? Because I think it's like not even really a real high vacuum, right? It's like just kind of a pressure drop.
Yeah, that's right. And I just brought Tim in. You might even know that. Unfortunately, Joaquin is not on, Jochen rather, who has done some calculations. But Tim, you might have already. No, yeah. So we're still trying to figure that out.
Okay, yeah, I think that would be an interesting thing to know. I think based on our sorbent choice, what kind of pressures we're aiming for. Because the difference between like a low vacuum and a high vacuum is a pretty big change in the bill of materials. So that'd be a good thing to figure out, I think.
I mean, I don't think it's a very high vacuum at all. And just even looking at the kind of pumps that the original Octavia carbon were using, you can see they're not very significant. So I don't think you have to get down to particularly low pressures at all.
Yeah, we know it's not big, but getting the exacta is one that a couple of us are working on. And I'll actually probably go back and ask the Octavia guys what they think would work. But you're right, that obviously has implications for the bill of material, but nothing crazy like NASA lab or anything like that. Probably something pretty off the shelf. So.
Yeah, and there's probably kind of like an optimization part to it as well, I think, where, like it might be theoretically better to draw a higher vacuum, but like if we can't, then sort of like what's the sweet spot in terms of engineering difficulty and effectiveness, I think.
Yeah, exactly.
Yeah, I mean, I guess we don't really care about contaminating our CO2 that we're desorbing and when we compress it at all. So
right.
And then I guess the question is, does it actually, at what point does it make any difference to how quickly the sorbent desorbs? Is that the kind of thing we're mostly worried about as well with low pressure? Yeah. I don't know whether is that a very significant effect.
Even I picked that up. I think Seth and Ling, right? It's speeding up the process as well of desorption, right? Is a big reason to actually use a vacuum. So I'll show some pictures here of just to kind of orient people towards what we're talking about with the chamber. Let me go down to one here. Oops, here. So that's probably not the best picture. How about this one here? Here we go. Okay. I'm waiting for that to change. So this area here is we got from off the shelf parts like duct work that's used for HVAC equipment. and it was kind of ideal, right? Like in terms of the general shape of it. And it was easy to buy. And then we were able to insert our sorbent panel right there in the inside so that the fan would suck through the air and it would go right through that panel. And again, this is what the panel looks like when you have it outside, and this is how it was sliding in, right? But some of the issues that we experienced with that, I guess there's two main ones, and guys, add to it if I'm forgetting anything. And it's all laid out in the digital deck. We have little videos of David talking through it. But this part here, the sealing of it created some seams. And obviously for both vacuum and just for, we want to enclose this, it's got to be really, really snug. So that was one issue. And then the other issue is we just don't know under any kind of vacuum, even if it's really weak, is this going to implode basically, like a tin can if we apply a vacuum to it, or what level of vacuum could we apply? So those are the two reasons why we want to sort of rethink that. And based on what we do with this, it has implications for how the sorbent panel is done and really all the other parts. And so it's kind of an important next step for us, I guess, to have sort of another idea. Ling and Seth, I wasn't on the call with Jake, but even just that or other ones, I'm just curious what our leanings are. I mean, did we want to try to apply a vacuum to this once we have that number, and just at least that'll help us test out some other things about how quickly we can sort of, speed up the desorption process? What do you guys think is the next sort of thing to do? Or do we want to just go with something completely different or a thicker version of this?
I mean, I always prefer to work with what we've got before changing it out, right? I think there's plenty of experiments we can run on this system and learn a lot to inform what the next version might look like.
We don't have a vacuum on our setup even, so how do we know that we want to switch out the housing? Oh yes, and regarding Jake's presentation of his design, it wasn't really like adjacent to our design. It was like something pretty tangential, because he was aiming for something that's more mass manufacturable. So I don't remember what he said about the vacuum on his design, but it was just like a totally different approach.
Yeah. I think the concern we had really came directly from David and Chuck about the vacuum, is that they were concerned that even if it didn't break on the first one, that it just the wear and tear of that would ultimately, we want something that won't degrade from a vacuum being applied to it. So that was sort of coming from them. I don't see there's any reason why we don't go ahead and test it out on this one, at least, if we can modulate the level of vacuum. And that would allow us to get the other sorbent and, or even use this one and compare it to the data we got from the first one. So yeah, I'm all fine with that. I did email, I copied some of you guys on it, Peter Saris at UPenn, and shared the digital deck, which he needed, and to see if we can get, some people on the ground there that could actually do the test. Would be, hopefully we'll get an affirmative response from him, but I think we've given him enough to hopefully get someone in for that.
So I just don't think that the sorbent chamber body can be swapped out in the vacuum, and I think that from what the calculations looks like, the sorbent really needs to be swapped out first, and then we need to optimize the sensors, and then we can do other stuff. And then because right now we're testing without a vacuum and we're getting weird results, and then we should really be getting results that allow us to say, hey, it is capturing CO2. And I'm not really sure. I think we are capturing CO2, but I think there's still some iffiness on how well the sorbent works. But it's like low effort and just money to swap it out. And then the sensor might be like more of a focus that. Yeah, I know this session's supposed to be about sorbent chamber, but I just don't see how I don't know if it's the most logical thing to focus on first.
So would you guys say get the sorbent? And Seth and Ling, when you talk to the sensor guy, we had a sense that there's another product that we'd probably want to get, but were there also issues that we thought were related to the actual shape of the chamber that related to the noise at all, or is that not a concern?
Maybe like this entire use case is not fit for the sensor, but
Yeah.
but we have to work with what we got. Yeah, the sensor is used for evaluating the room air quality for like a room that may have a bunch of people in it, and so it responds slowly for that reason.
Okay. So
Yeah.
what do you think though, Seth? Do you feel like we got enough from them? Like, all right, well then let's try this one, which we can do. I think that we could probably swap it out, right? So we could swap out the sensors and the sorbent first before we do anything chamber related.
Yeah, I agree. I think we definitely should try the new sensor first, see what it buys us. It's going to be faster responding. It's going to be more resilient to some of the turbulence that we're seeing. And that's really where I think the shape comes in, right? None of these are very good with turbulence. And Lynn made that housing to try and cut down on it. So, it's possible that some of the differences we were seeing between the front side and back side sensors were due to that turbulence, because one was on the slant and one was on the level tube. But I think these are clearly the wrong sensors, so I don't see much value in going forward and running experiments with the wrong sensor. Let's get what we think are going to be the closest to the right ones we can, so that we're getting the best data we can get.
Okay. So I would say that we go ahead and order that in the sorbent now. And based on what we do have someone, he's graduating in a couple months, but he is at UPenn. He can't make this time, but he has, said he would be happy to help. I think he's a chemical engineer, Ling. I can't remember if he's a chemical or a mechanical engineer, but he,
yeah, I don't know, but grad students are very flexible.
Yeah. So I'll see from the UPenn side if they can receive it, and we could go ahead and swap those out. We can go ahead and do the first test. So if you guys give me your thumbs up on that and send me the link to that other sensor, I have the sorbent one. I'll go ahead and place an order, this week if the UPenn team can receive it. You see a question here? Okay. All right. Cool. I did. If anybody, yeah, go ahead.
Sorry, quick question. Is there just one sensor that's a carbon dioxide sensor, or are there multiple sensors? Just quick question that I had missed.
There are two sensors, one at the inlet, okay. One at the outlet. Yeah, the whole device is pretty, if you look at it, it's like a little bit self-explanatory. It's like a funnel on one end and then another funnel going out on the other end. So we're just measuring it twice. Yeah. One on the inlet side, one on the outlet side, where the thinner neck is, or near the thinner neck part.
Yeah, can you see those two little things? I don't think I can. I'm not sure if I can scroll over it, but you can see those little kind of knobs that come out of both ends.
Yeah,
yeah, and then there's the fan. Yeah, and that's basically
where the sensors are. Okay.
Yep, exactly.
Thanks for that.
Yeah, no problem. And it's both it's CO2 and pressure, right? Is there a couple things that are measured by that, or is it just CO2? I can't remember.
CO2, temperature, pressure.
Okay, great.
And I think they do humidity as well.
Yeah, that might be right. Cool.
Just as this quick question, all these problems with turbulence, the measurements with the CO2 sensor have been done when we've been blowing, air's been blowing through the instrument, right? I'm just wondering whether, as a stopgap measure, if you wanted to take a CO2 measurement, you could stop the fans momentarily, let everything settle, which might not take very long, take a measurement, and then start going again.
Yeah, we can certainly do that. I still think, if our man on the ground is looking to run some experiments now, then that could be useful. But that settling time is going to be a lot longer with these sensors than it will be with the others, like by an order of magnitude.
What does that mean, Seth?
It means 10 plus minutes versus a minute or two or less. I mean, I think he said if everything's working right with these new sensors, then they could settle in under a minute.
But settling is just that it calms down and it's able to get a clear read. Is that what settle means? Sorry.
Essentially.
Okay.
I mean, yeah. Yeah. And then there's some other things that we wanted to do with it, like use a sliding window to smooth out the results, because we're seeing a lot of spikiness, and that's to be expected. So there are things that we can do to get better, cleaner data out of them. And a lot of those techniques would apply to both sensors. But I think, you know, if we've got the opportunity to change out to a better sensor, we're better off doing it now. But as I said, if he's looking for things to do while the new sorbent arrives, the type of changes and the type of code he'd need to write to run these sorts of tests with the old sensors would directly apply to the new sensors. So it's not wasted work at all.
Ling, is the size of it, or the new sensors, is it the same where we could still use the same 3D printed case that you?
I'm not sure. I have to examine, but if it's different, then I can just make a new one.
Okay.
I think they have a different footprint.
All right. Well, we make a new one, and then you can just send the files to UPenn, and they could probably print it there. I know they have 3D printers. Would be great.
Yeah, I just printed it at work, and then donation from my work.
Yeah. Can I ask a kind of a dumb question, but one I'm kind of eager to know is when we think about physically applying a vacuum to this, ultimately, we have diagrams where it just shows in a box vacuum and an arrow pointing at it. What does that look like optimally? How would a physically a vacuum actually be integrated into this? Is it about drilling a hole and sealing it here, or what are our thoughts on that?
Yeah, I think we need to make a hole somewhere, either where the cone shapes are or in the middle, because so the dampers I believe are like I don't know where exactly they are. Seth, you might know that better. They're near the ends.
This is the damper. Yeah, I think, isn't that right next to your sensor, or isn't that even the sensor on the damper?
I don't think this picture has the sensors because the sensor boxes are black.
Yeah, Chris, I think those knobs you were pointing out are the dampers.
Yeah.
Okay.
Not the sensors.
Gotcha. Okay, and that would make sense that they're on either end because they basically have to just close the.
Yeah, because if you look at this picture, the inlet sensor, if I remember correctly, the inlet sensor is actually on the curve of the cone, just past the damper on what's on the left on screen, and the outlet is actually basically where that 3M tape is to the right of the cone.
Yeah, I'll have to. I uploaded the wrong picture here, but yeah, it basically goes right on the bulb there, and then the other one's on the duct. Let me see if I can grab a picture of that later. Okay, exactly. So it would be a matter of just sort of having a vacuum tube go into there, and it's sealed. It just sort of plugged into the side like a catheter, for lack of a better term, or whatever, colostomy bag. I don't know, some other gross medical thing. But it's a relatively simple integration as far as we know.
As far as we know.
All right, cool. All right, well, I'll go ahead and make those 2 orders. And if we're gonna then apply a vacuum and see how far this gets us, I agree with you. If we can use what we got, and if it looks like it's gonna stand up, or if it's a matter of ordering just a slightly thicker one that won't require a real form function change, That's great. But we also had the issue on the inside of the sorbent panel, where we wanted to fix this problem here, which was this is just too jammed in there, right? And this box is a little too tight, so it might need to be sort of spaced out a bit, which would also probably change the design of the panel, which would then also change the amount of space needed in the chamber, right? Because this just seems like the air was just blocking, and that was taking a lot more energy than it was very inefficient. So this is a very skinny little box that we have here, right there, that the panel fits into. And if we feel like that's too compressed of a space, then we're going to have to do a redesign of the chamber in any event, right? Unless this could just be fatter. I don't know, but
Hold more sorbent.
well, it's not just about sorbent, it's just more area so that it's not like, again, this picture, this is like, I think what we agreed on, this is like the air wasn't able to flow through that. So we wanted to kind of make it breathe a little bit more. But if you don't want to reduce the amount of sorbent, then you need a larger area in which to put the sorbent, right?
I think maybe like it needs to be thinner. So this is why Sandelia was saying that a lot of the designs out there, they have like vertical, instead of going left or right, they're going like top to bottom, and they have stacks of sorbent, and then they're thinner. So the reason why this one doesn't have a large area is because of the inlet and outlet sizes. So the opening of this, like this was never explained to me, but I assume that that's the reason, and I think like everyone else will find it intuitive as well. You don't want to open up the airflow area too much in the middle of like between the ends of the cones, because then the air will have to expand. When the air has to like fill that area, it can't go as fast. So you don't really like win a lot by opening up the area, because like wherever there's the least amount of resistance, it'll just go through there. So if you have a large area, you still need it to go through the entire area. We don't really get to, skip out on that part. But like maybe the thickness of the sorbent chamber is too thick. That's a possibility.
I thought we were worried it was too thin just from vacuum perspective. That was what David had raised, is that he thought it might be too flimsy, that we would need something a little.
Oh, you're talking about the chamber walls. No, I'm talking about the sorbent chamber.
Yeah, this is the chamber and then the panel.
Yeah, so if you remember, like from the conversation with Sandelia, he's saying that like the commercial ones that are out there, they're always very thin. Like the sorbent thickness is always very thin. Ours is 1.5 inches, which is very thick.
Which is 1.5 inches though? Sorry, I'm getting a little confused about what you're describing. The
sorbent, the sorbent itself. The thickness of the sorbent itself.
Gotcha. Okay. Well, unless I was kind of hallucinating last week or in previous conversations, just let me know if we feel like this isn't a problem to have it all packed in there. That just from an airflow perspective, did I read that wrong, or is that actually something?
It's potentially a problem. I'm not denying that. What I'm saying is that making this area bigger might not help.
Yeah. The only reason I was thinking bigger was because if we want to have the same amount of sorbent, but you need to have more space for airflow, then that would entail a larger total area in which the sorbent has to be placed, because there would be more air.
Yeah, that I cannot say. So I think maybe worth trying, but it's a lot of work.
I think that sounds like a great experiment for a build sprint.
Yeah.
I mean, someone has put their hand up against the on the other side of the sorbent and actually checked there really is air flowing through that when the fans are on.
Yeah, we'll have to ask David if he
No,
did that
sure.
or how. Yeah, I'm not sure either. I mean, I'm sure he probably did, but we'll see what kind of hand test he did. would be good.
Mhm.
All right, cool. And David's back next week, so we'll ask him in the meantime. All right, cool. I had one, because we can do that on these calls, obviously, as I did, again, not as a redirect of any sort, because again, if this can work as is with new sensors and new sorbent and a couple of other tweaks, phenomenal. That's what we want to have happen. But there was an idea, if you guys, does anybody have any other points or questions about what we just discussed? Because I did want to show just a kind of a zany idea for a hack for the chamber. But before I do that, I didn't know if Alex or Scott as newbies, or if anybody else has any other questions or ideas to raise based on what was just discussed.
No,
No,
good
not
here.
right now. Thanks.
Okay, cool. All right, so you guys, it landed with deafening silence, which may have been all I needed to know when I posted it on the Discord. But I did have just this, I thought, kind of a quirky idea for sort of an Instadac type of hack here. Because as we were thinking through the, what kind of pressure do we need in order for this to, withstand a vacuum, make sure it's really, really a tight seal. I was looking through these various different versions of Instapot, and the largest electronic pressure cooker like this that I found was affordable, and it's been around for a long time, and it's 14 quarts. And there's a couple of cool advantages, I think, to that is one, I'll start here, is that, again, it could solve our sort of pressure issues. It has this electronic panel, and I did look on Hackaday and Make and on Reddit, and there are people who hack the electronics of Instapots. So the idea of coming up with a panel here, somebody was hacking it for both PSI and temperature, but it could be an interesting thing that you could look at is, could we optimize this maybe for the way in which we need to change the commands on it? And then obviously it's off the shelf. The other thing I think that's pretty cool about it is that it has all kinds of accessories that actually fit into it that you just open up and you just put in. That's at least some of the early stuff we talked about with like getting more air. How could you embed sorbents? I mean, there's like 12 different varieties of this type of thing to put different types of objects in it. So it could be just an interesting thing where you open it up and you have different kinds of housing for the sorbent that you could put in. One that sort of maximally loads it, maybe one that has just a small thing that you'd normally put a hard-boiled egg on, but that's that small amount of sorbent that we would use just for basic testing. And then it also has all sorts of other accessories, including, these kinds of carts and things like that you can kind of roll it around on, things that can segment it as well. It's usually used for steaming, but if you wanted to have, integration of mineralization or something. So anyway, I just thought it was an interesting avenue for us to, potentially geek out on. The big issue with it, obviously, is that, you change the integrity here of this pressure pot if you're trying to drill a hole and insert, these other ductwork into it. I think is probably the biggest thing that would add the biggest question marks around it. But anyway, just wanted to, as a non-engineer, kind of share that idea for some initial thoughts. Not something we're doing tomorrow, but could be an interesting hack down the line.
Chris, Instapots do the opposite of create vacuum.
They wouldn't create a vacuum. It's just more the way that they're built, right? They're very, very heavy duty, and they have a seal with a gasket on it that you shut and lock. That is that also spec'd for the kind of durability we need for something like this?
Maybe, but only in the sense of like the mechanical build. But the actual Instapot itself, what they do is that they use some kind of liquid, usually like a soup, and then it evaporates, and then it creates high pressure using like steam from the soup or like liquid. So it's the opposite of a vacuum. If we want to like borrow the setup, we could, but I don't know how to like integrate like if we mechanically integrate some air ducts with an Instant Pot, then the failure point is probably gonna be where we do the integration.
Yeah, that's what I was pointing out on my last slide there. Yeah, no, definitely not expecting an Instant Pot to be a vacuum chamber out of the box. It's more as the thickness of the design and the ability to seal it on top with a gasket and lock it, and then it has electronics and it has a heat source which could be hacked and changed. Is that enough to make it a potentially interesting avenue? But yeah, you're right. Is I think those fail points is you'd have to, weld it something that you could put on that would allow air to come in and dampers without it, leaking immediately. That does seem like the biggest question mark.
I like the idea. I can definitely imagine the vacuum part. The airflow seems like a big challenge. Like, I don't know how you do that without destroying the integrity of the machine. But yeah, I mean, yeah, I just posted in chat, like if you replace that release valve mechanism with something with like a barbed fitting on it,
yeah,
put a vacuum pump on the other side, seems like it would work. I mean, it's definitely not designed for that, but it can handle pressure. So, and I've seen people use regular sort of non-electronic pressure pots as vacuum chambers before. There's some YouTube videos of people doing that, but I have never seen anyone do it with an Instant Pot.
Yeah, I just like the plug-in source of heat.
Yeah,
could be cool, but again, just wanted to kind of put it out there to see if it would land with anybody. But I also wanted to see Malcolm, who's tuning in on the stream, did ask a question. Hey, Malcolm, good to see you again. That is not quite related, but I wanted to at least ask it. So what if the sorbent is let free to be shaken by the inflow? Maybe it would maximize the random contacts with the air incoming CO2 molecules. That is an idea actually that David came up with. If you guys remember that fluid bed thing for cyan, where it was an idea that you just have it floating around sort of at all times for that purpose. And I know he kind of hit a wall on that with cyan, but I think there was still interest in that, potentially. But I don't know if you guys have any thoughts on that idea, the fluidized bed kind of approach.
I do know that open air contributor Xiao Yu has a fluidized system that he's working on. Some really good examples of how that works. Very slick looking fluidization chambers that are clear and you can see the sorbent floating around. It's very cool. I'm not quite sure how you'd apply it to this, but he's definitely made a ton of progress there. So it's cool to see.
Are they small?
Yeah, they're probably about I'd say like 3-inch diameter tubes that are, maybe like the size of like a big gulp.
Nice. Okay, that sounds interesting to look at. Well, Xiao Yu in Waterloo?
That's right. Yep.
Yeah. Okay, cool. I'll ping him on the Discord and see if he can talk to us at some point. All right, cool. Well, if anybody has anything else to discuss, I wanted to, just kind of recap on what progress we can make between now and next week. But yeah, let me know if anybody has anything floating around their head or any questions or cool ideas. All right. So what I'll do is I'll hopefully we'll hear back from you, Penn. I'll in fact even invite, if they happen to be around, if someone on their side might want to jump on this call so we can sort of say very specifically what it is that we want to test out and the equipment that we're adding. So I emailed him early this morning, so we'll see if there's any opportunity to do that. I'll go ahead and order those two components, both the sensors and the new sorbent. I don't know how long they take to get here, but maybe we'll have a unboxing by next week. And then, yeah, I think those are the two main ones. And then we might have some new additions to the GitHub by next week, potentially, Ling. But we'll obviously keep people posted if there's any updates to it. I feel like there's
I think once Janine gets access this afternoon, we just have to push some updates. Like we already have it ready.
Okay, cool. So I'll let Janine. Hey, Janine. I'll let Janine into it. I have one call right now, but as soon as I'm done with that,
Okay.
you'll get it, and we'll see.
Thanks. Well, appreciate it.
All right, cool. All right, guys, we can give you back 13 minutes, but thanks everyone for joining. Unless somebody has any final thoughts, otherwise we'll see you folks next Monday. All right, cool, guys. Thanks.
Thanks,
See ya.
everyone.